Okay, in this video we're going to find the equivalent resistance of resistors in parallel. So we're going to be using our same old parallel resistors equation. 1 over R equivalent equals 1 over R1 plus 1 over R2 plus 1 over R3. So let's look at just our first resistor over here. We have a 10 kilo ohm resistor in parallel with a 25 kilo ohm resistor. So we want to find R equivalent. We know that R equivalent to the minus 1 is equal to R1 to the minus 1 plus R2 to the minus 1. So we're going to plug in our numbers. That's going to be 10 to the minus 1 plus 25 to the minus 1. And our units are going to be, well, they're going to be kilo ohms to the minus 1. And we're just going to have to plug that into a calculator. And that's going to simplify to 0.1 plus 0.04 per kilo ohm. 0.1 plus 0.04 is, of course, 0.14 per kilo ohm. And remember, that is R equivalent to the minus 1. So to find R equivalent, we're actually going to have to take the reciprocal of both sides, or raise everything to the minus 1 power. Minus 1, minus 1, minus 1. And we're going to get our final answer. R equivalent is equal to 0.14 to the minus 1 is 7.1 ohms. Parallel resistors reduce our overall resistance. Let's do the same thing on this second set of resistors. We have 80, 120, and 50 ohms. So I'm going to write it out. 1 over R equivalent is equal to 1 over 80 ohms plus 1 over 50 ohms plus 1 over 120 ohms. And all we have to do is plug that into our calculator. 1 over R equivalent, or R equivalent to the minus 1, is equal to 80 to the minus 1 plus 50 to the minus 1 plus 120 to the minus 1. It's going to give us a number 0.04083. And the units are going to be per ohm, so ohms to the minus 1. And again, we've just solved for 1 over the equivalent resistance. To find the equivalent resistance, we need to take the reciprocal of that, or raise it to the minus 1 power. We raise it to the minus 1 power. We get our equivalent is equal to 24 ohms. About 24.5, but to 2 sig figs, 24 ohms. We have less resistance overall because we have more paths. Let's look at our third problem. And this actually gives us a full circuit. We have our source of EMF here, and then we have 1, 2, 3 resistors in parallel over here, and a 4th resistor over here. Now, the key to this is you can kind of figure out that R4 is actually in parallel with R1, R2, and R3. Because, if you remember, this whole wire is one equipotential surface, so you can rearrange the order of that top wire as much as you want. And in fact, I'm going to redraw this circuit, just kind of a simplified version of this circuit, so that it's easier to work with. I'm not going to add numbers, but we could also draw this like this. Where we have R1, R2, R3, R4. That doesn't affect the analysis at all, but it's a little bit easier to see that R1, R2, R3, and R4 are in parallel. So let's actually get with the solving then. I'm going to use red. R equivalent to the minus 1 is equal to R1 to the minus 1. Well, I'm just going to plug in my numbers. 55 mega ohms to the minus 1 plus 20 mega ohms to the minus 1 plus 110 mega ohms to the minus 1 plus 20 mega ohms to the minus 1. And then we plug that into our calculator to get our answer. 55 to the minus 1 plus 20 to the minus 1 plus we get 0.127, 27 repeating. Units are going to be per mega ohm. So that's our equivalent to the -1. We have not solved it yet. We still need to take the reciprocal of both sides, raise everything to the -1 power again to get back to our units of resistance, and then we get our equivalent is equal to 7.9 ohms. Much less resistance when we add a bunch of resistors in parallel. That's that.